Hello and good day to all. We are grade 12 STEM students, or Science, Technology, Engineering, and Mathematics students of Holy Cross High School. Today, for this video, we will be talking about chemistry for senior high school. Specifically, we will be talking about Chapter 3, which is all about chemical compounds. So now, before we get to the lesson proper, let's talk about our learning objectives. What do we want out of this video? At the end of this lesson, the student is able to, or should be able to, first, identify what ionic and molecular compounds are. Second, they should be able to differentiate between monatomic and polyatomic ions. Next, or third, they should be able to name and write formulas for ionic and molecular compounds. And lastly, they should be able to describe what acids and bases are. So in order for us to achieve our learning objectives, we must have an agenda. So moving on to our agenda, it is as follows. So up first, we have lesson 3.1, which is all about ionic and molecular compounds. Up next, for the second lesson, we have lesson 3.2, which is going to be all about monatomic and polyatomic ions. Third lesson in our agenda is 3.3, naming ionic compounds. Fourth on our agenda, we have lesson 3.4, which is all about naming and writing formulas for molecular compounds. And now for the last part of our agenda today, we have lesson 3.5, which is all about acids and bases. So without further ado, let's start our lesson. So, lesson 3.1 is all about ionic and molecular compounds. So before we start talking about ionic and molecular compounds, let's first go back to the basics, the root word of these two compounds. We have ions and molecules. So what are ions? What are molecules? So let's start off with ions. An ion is a positively or negatively charged particle. So a positively charged ion is called a cation, while a negatively charged ion is called an anion. On the right-hand side of your screen, you will see some examples of ions. So the first example that we have is magnesium, or Mg. So as you can see, magnesium has two positive charges represented by the 2 plus sign on the upper right of the circle of magnesium. So it has two positive charges, therefore making it a cation. Now, for the one in the middle, we have oxygen, which is represented by the letter O. As you can see, it has two negative charges, represented by the 2 and the negative sign next to it. So, since oxygen has two negative charges, therefore it is an anion. And lastly, we have the atom K, or potassium. And as you can see, potassium has one positive charge, therefore making it a cation, since it has one positive charge. So now that we know what ions are, we will now move on to the second question. What are molecules? So to answer that question, molecules are neutral particles made of two or more atoms bonded together. So for the illustration that you now see on the left-hand side of the screen, we have an example of a molecule, a very common example at that. It is an H2O molecule, or a water molecule. As you can see, there are two hydrogen atoms, and they are bonded together with one oxygen atom. therefore making H2O, or what we know as water. So now that we have learned about what ions and molecules are, we can now move on to ionic and molecular compounds. So let's start off with ionic compounds. So what is an ionic compound exactly? To answer that, an ionic compound is composed of oppositely charged cations and anions in proportions that produce a zero net charge. Some examples of ionic compounds include NaCl, or as we know it, sodium chloride, or more commonly known as table salt. Next we have KCl, or potassium chloride, and lastly we have NaBr, which is sodium bromide. So here we have a visual representation of NaCl, sodium chloride, or table salt in other words. So this is how NaCl works as an ionic compound. So as we learned, an ionic compound is composed of two oppositely charged ions, one cation and one anion. And then they are in proportions that produce a zero net charge, and that is exactly what NaCl does. So, as we all know, Na, or sodium, has one positive charge, while Cl has one negative charge. So, one positive charge and one negative charge equals to zero. Therefore, it is an ionic compound. So Na has one valence electron in its outer shell. As you can see on the illustration, the left side of the illustration, you can see that there is one valence electron for Na. And for Cl, there is 7, and it lacks 1 to complete its valence electrons. So what Cl does is that it takes the one positive charge or one valence electron of Na in order for both of them to have complete outer shells or valence electrons. And so with that, it makes NaCl an ionic compound. Moving on to the next piece of information on ionic compounds, we have its structure. So the structure of ionic compounds are arranged in what is called a crystal structure or a crystal lattice, as you can see on the illustration on the right side of your screen. And this lattice, this is what breaks down when it is dissolved in water. So now that we've learned the definition, some examples, and the structure of ionic compounds, we can now move on to the second part of this lesson, which is molecular compounds. So what exactly is a molecular compound? Let's find out. A molecular compound is composed of atoms from two different nonmetals. It consists of molecules whose formula represents the actual number of atoms bonded together in the molecule. Now that we know what molecular compounds are, let's now move on to some examples. So the first example that we have is H2O. This is a very common example of a molecular compound, as we know H2O is water. The second example that we have is CH4, which in other words is methane. And lastly, we have CO2, which is in other words carbon dioxide. Again, you can see on this illustration H2O. You see two hydrogen atoms and one oxygen atom bonded together to form H2O. Now that we know some examples and the definition of molecular compounds, we can now move on to the next piece of information. We have the structure of molecular compounds. So the structure of molecular compounds is arranged in a distinct group of atoms that are held together by chemical bonds. So on the illustrations, on the left-hand side of your screen, you can see the different chemical bonds that have been mentioned. So first we have the hydrogen bond. You see two hydrogen atoms and they are bonded together by what we call a single bond. Now for the second part, we have two oxygen atoms and they are bonded together by what we call a double bond. And lastly, for nitrogen, they are bonded together by what we call a triple bond. So these are some chemical bonds that we should know about. So moving on to differentiating between the two. So differentiating between an ionic compound and a molecular compound. When ionic compounds separate into components in water, we call the process dissociation. So on the left illustration, you can see that in the flask with water and the particles in the water, you can see that they have separated into ions, and that process is called dissociation as mentioned. Now, on the other hand, molecular compounds remain the same, and they usually stay together when a substance dissolves in water. Now, this is represented by the illustration on the right. You can see that the substance is still compact in its structure, and they are still together, unlike the illustration on the left, where they have separated into ions. For this illustration, you can see that they are still together and they have the same composition. So in relation to that, substances that separate into ions when dissolved in water is called an electrolyte, while these substances that stay intact and do not separate into ions are called non-electrolytes. And so with that, we have come to an end to our lesson, but before we move on to the next lesson, let's have a short recap on the key points of this lesson. So first key point is that an ionic compound is made up of oppositely charged cations and anions in proportions that generate a net charge of 0. Second key point, a molecular compound is made up of atoms from two different nonmetals rather than ions. Third key point, when ionic compounds break into components in water, we term the process dissociation, which distinguishes between an ionic and a molecular substance as molecular compounds stay intact in water. And last key point is that an electrolyte is a substance that separates into ions when dissolved in water, while a non-electrolyte is a substance that does not separate into ions and remains intact.
Let's move on to lesson 3.2, which is all about monatomic and polyatomic ions. A monatomic ion is an ion of a single atom, whereas a polyatomic ion is an ion containing two or more atoms. Here are the rules in naming monatomic ions. First, monatomic anions, or ions with a negative charge, are named using the root name of the element, and the suffix IDE or "ide" is added at the end. Second, monatomic cations, or ions with a positive charge, retains the name of the element and is referred to as name of element ion. Here are some examples of monatomic anions and cations. We have their formulas and their names. Let's start off with the anions. We have F negative or fluoride ion, O2 negative or oxide ion, S2 negative sulfide ion, N3 negative nitride ion, and lastly P3 negative or phosphide ion. Moving on to the cations, first we have H positive or hydrogen ion, K positive or potassium ion, Ca2 positive or calcium ion, Mg2 positive magnesium ion, and finally Al3 positive or aluminum ion. Now we have the second topic of this lesson, the polyatomic ions. The most common polyatomic ions are oxoanions, which contain oxygen attached to some other element. They are typically combinations of oxygen with a nonmetal, although some of them do contain metals. Rules in naming oxoanions. Remember, if there are only two oxoanions of an element, the one with a greater number of oxygen atoms is named by combining the root name of the nonmetal element and the ending "ate." The oxoanion with a lesser number of oxygen atoms uses the ending "ite." So here we have 6 examples of polyatomic ions. Just like the monatomic ions, we have their formulas and their names. Let's start off. NO2 negative or nitrite, NO3 negative or nitrate, SO3 2 negative sulfite, SO4 2 negative sulfate, PO3 3 negative phosphite, and PO4 3 negative phosphate.
So now we will be moving on how to name ionic compounds. Ionic compounds are named by naming the cation followed by the anion. For ionic compounds containing common monoatomic ions, you must give the name of the cation first, using its element name. To name the anion, add the suffix "ide" to the root of the name of the element that corresponds to the anion. Generally, for ionic compounds, a prefix indicating the atomic ratio is not used. Naming ionic compounds containing polyatomic anions is similar to naming compounds with monoatomic anions. The cation is named first, followed by the name of the polyatomic ion. So now we move on to naming ionic compounds containing metals that exhibit multiple charges. In naming ionic compounds containing metals that exhibit multiple charges, we use the stock system, which is the systematic method used to name ionic compounds. The stock system uses a Roman numeral in parentheses after the name of the metal to indicate the charges. Constructing formulas using stock system names is particularly straightforward since the name gives the charge of the metal. Here is an example of ionic compound names using the stock system: CuCl, copper chloride; CuCl2, copper 2 chloride; FeS, iron 2 sulfide; Fe2S3, iron 3 sulfide; Hg2Cl2, mercury chloride; and HgO, mercury 2 oxide. Now, formulas for compounds containing metals that exhibit multiple charges. While the systematic stock naming system directly communicates the charge on the metal when talking about ionic compounds, an older method of naming such ionic compounds is still used in labels of consumer products. In this older method, the name of the metal is changed by adding suffixes, either "us" or "ic", to the root of the original Latin name of the metal. In the cases of iron and copper, the Latin names of the elements are used: ferrous or ferric, and cuprous or cupric. Though this older method is not often used in laboratories, since it only applies to metals that exhibit two charges. The suffix "us" indicates the lower of two charges. The suffix "ic" indicates the higher of two charges. Now we'll have a video presentation for ionic compounds. Naming ionic compounds isn't too difficult, but writing the formulas involves balancing charges, so it's a bit more work. So with all these rules to guide us, let's try one, which is sodium chloride. As we know, chlorine is a metal and sodium is a nonmetal. That means we have an ionic compound. First, we write the symbols for each element. So for sodium, that'll be Na. And we have chloride, which is chlorine in the periodic table, and that's Cl. And then we need to find the charges. If you remember from the periodic table, sodium, which is in group 1, has one positive charge, while chlorine has one negative charge. A positive and a negative charge will cancel out to give us a net charge of 0. And because of that, the correct formula for sodium chloride is just NaCl. So when the charges are the same, it's straightforward. For potassium fluoride, we write K from the periodic table for potassium, and then for fluoride, which is fluorine, we write F. And then we write the charges. Potassium has one positive charge, and in the fluoride, we have one negative charge. Those will both cancel out to give us a net charge of 0, so that makes this Kf the correct formula for potassium fluoride. Calcium chloride is a little bit trickier. We can look up calcium, that's Ca, and then the chlorine, that's the Cl. But when we go to the charges, we will notice that calcium has two positive charges, and the chlorine has one negative charge, so the charges aren't balanced. So we need to get the net charge to 0. What we can do is change the subscripts, so I could put a 2 here. That means I have 2 chlorine atoms, and each one is a negative charge. 2 times 1 negative charge, that gives me 2 negative charges, and that will cancel the charges out, and they will be 0. That will make CaCl2 the formula for calcium chloride. For magnesium bromide, we write Mg, and then the bromide, that's the bromine, so Br. We can see this has 2 positive charges, and we have a negative charge, so we'll need 2 Brs. 2 times a negative charge will give us 2 negative charges, so that will cancel out, and we'll have a net charge of 0, and that makes MgBr2 the formula for magnesium bromide. For sodium nitride, sodium, Na, and then the nitride, that's the nitrogen, is N. Sodium has a positive charge. Nitrogen has 3 negative charges. So we're going to need 3 sodium atoms. 3 times a positive charge gives us 3 positive charges to cancel out the 3 negative charges. That makes the formula for sodium nitride Na3N. For naming and writing molecular compounds, we will be starting with a video presentation. Moving on to molecular compounds. Today I'm going to be demonstrating for you how to write a chemical formula for molecular compounds. So let's say we were given the name sulfur dioxide. How can we write the chemical formula of this compound? Now the first thing you need to know is that you need to understand what the prefixes represent. Whenever you hear the word mono, it is associated with 1. Di is associated with 2. Tri is 3, tetra, that's associated with number 4, penta represents 5, hexa is equivalent to 6, hepta correlates with 7, octa is equivalent to 8, nona equals 9, and deca represents 10. So when you hear the word sulfur, sulfur has the chemical symbol S. Dioxide, di, is 2, so there's 2 oxygen atoms, so it's going to be SO2. More examples are sulfur trioxide and dinitrogen pentoxide. So for the first one, we have the element sulfur, so that's S, and then trioxide, that's 3 oxygen, so it's going to be called SO3. Dinitrogen pentoxide, di represents 2, so we have 2 nitrogens. Penta is associated with 5, so there's 5 oxygens. Therefore, the chemical formula is N2O5. A few more examples are nitrogen monoxide, sulfur hexabromide, silicon dioxide. So for the first one is nitrogen. Nitrogen is a single nitrogen atom and then monoxide, so that's 1 oxygen. Sulfur, that's S. Hexabromide, hexa, that is associated with 6, so SBr6. Silicon dioxide, silicon is Si and di represents 2, so it is SO2. To sum it all up, when naming a molecular compound, keep in mind that its name should always correspond to the specific number of atoms of each element in the molecule. To name molecular compounds systematically, name the elements in the order they appear in the formula given. Remember that you should add the suffix "ide" to the root of the second element. If you weren't given a formula, the first element is usually farther to the left and further down on the periodic table.
On to the next lesson, we have acids and bases. Let's move on to the first topic of this lesson. What are acids exactly? Let me help you with that. Acids are compounds that usually contain a hydrogen atom that can be removed as an H-positive ion when the compound is dissolved in water. Do you know what ionization is? If you don't, then keep watching. Ionization is a process that happens when a compound that is not ionic provides ions when dissolved in water. A hydrogen ion, or H positive, does not actually exist in solution as an isolated entity. Instead, it is surrounded by several water molecules. An H positive ionic in solution is often represented as H3O positive, called hydronium ion, to show that the H positive ion is really attached to water molecules. In order to help you identify acids, here are some of their properties. First, acids are corrosive in nature. They are also good conductors of electricity. The pH values of acids are always less than 7. When reacting with metals, they produce hydrogen gas. And lastly, acids are sour-tasting substances. Examples of acids are sulfuric acid, or H2SO4, hydrochloric acid, or HCl, and acetic acid, or CH3COOH. Let's move on to the second part of this lesson, bases. Bases are substances that react with acids in an aqueous solution to form water. Most common bases either contain hydroxide ion, OH negative, or can provide OH negative ions in solution. Here are some properties of bases that will help you recognize them. First, bases are found to have a soapy texture when touched. These substances release hydroxide ions, or OH negative ions, when dissolved in water. In their aqueous solutions, bases act as good conductors of electricity. The pH values corresponding to bases are always greater than 7. And lastly, bases are bitter-tasting substances. Here are examples of bases. First, sodium hydroxide, or NaOH, milk of magnesia, MgOH2, and calcium hydroxide, or CaOH2. You may be wondering, what is the difference between acids and bases? Well, let me help you with that. The chemical difference between acids and bases is that acids produce hydrogen ions, whereas the bases accept hydrogen ions.
And with that, we end our lesson for today, which was all about Chapter 3 on chemical compounds. Thank you very much for watching this video, and we do hope that you learned something from watching our video and that you have achieved